In the vast expanse of our solar system, beyond the familiar blue of our own planet, lies a realm of celestial wonders. Among them is a small icy moon named Ymir, a world locked in a perpetual dance around the ringed giant Saturn. Ymir is a captivating world, a celestial time capsule that holds clues to the early solar system. Its surface, scarred and cratered, whispers tales of a violent past, of collisions and cosmic events that shaped its destiny. Ymir, named after a primordial giant from Norse mythology, is a fitting tribute to the moon's ancient origins. This tiny world, barely scratching the surface of our cosmic perception, is a testament to the sheer scale and diversity of the universe. It serves as a reminder that even in the darkest corners of our solar system, wonders abound, waiting to be discovered. Ymir's story is intertwined with the story of our solar system, a story that began billions of years ago in a swirling cloud of gas and dust. As we delve deeper into the mysteries of Ymir, we embark on a journey of cosmic exploration, unraveling the secrets of our celestial neighborhood and ultimately our own place in the universe. Saturn, the ringed jewel of our solar system, reigns supreme with its retinue of over 80 moons. Ymir, discovered in 2000, stands out for its secrets within its icy embrace. It follows a retrograde orbit, hinting at its captured nature. Ymir's study offers a glimpse into the formation and evolution of our solar system. Ymir, a relic of the early solar system, holds clues to our cosmic beginnings. Its surface preserves imprints of a bygone era, a time of collisions and cosmic events. Scientists believe Ymir formed in the distant reaches of the solar system. This region, the Kuiper Belt, is a repository of icy remnants. These remnants, known as KBOs, offer insights into the solar system's infancy. Ymir, once a KBO, was captured by Saturn's gravity. This capture event likely shaped Ymir's surface and composition. By studying Ymir, scientists hope to unravel its mysteries. Each crater tells a story of the early solar system. The year 2000 marked a significant moment in our exploration of the cosmos. Astronomers, armed with powerful telescopes, were peering deeper into the universe than ever before. Amidst this quest, Brett Gladman's team discovered a faint object near Saturn. This tiny point of light was a new moon of Saturn. The discovery was the result of years of meticulous observations. The team, based at the Canada-France-Hawaii telescope, was surveying Saturn's outer regions. Their goal was to find faint, irregular satellites. Using sophisticated techniques, they scanned Saturn's region. During one session, the faint object caught their attention. Its slow movement revealed it as a moon. Announced in October 2000, it joined Saturn's family of moons. The discovery of a new celestial object, however small, is always a cause for excitement in the astronomical community. But confirming the existence of a new moon requires more than just a single observation. It demands rigorous follow-up observations, meticulous data analysis, and independent verification from other astronomers. The team, led by Gladman, swung into action, eager to confirm their initial findings. They pointed their telescopes towards the faint object, night after night, carefully tracking its movement against the backdrop of stars. Each observation, like a brushstroke on a cosmic canvas, added to their understanding of this newly discovered world. Observatories around the globe joined the effort, their powerful telescopes trained on the distant Saturnian system. From the rugged peaks of the Andes Mountains to the arid plains of Chile, astronomers worked tirelessly, sharing data and collaborating to unravel the secrets of this enigmatic moon. The more they observed, the more confident they became. The faint object was indeed a moon, locked in a distant orbit around Saturn. The discovery, announced to the world in October 2000, added another member to Saturn's already impressive family of moons. It was a testament to the power of international collaboration and the ever-evolving capabilities of our astronomical instruments. The discovery of Ymir, initially designated as S2000 S1, marked the beginning of its story. Astronomers were eager to learn more about this newly found world. What was it made of? What did its surface look like? Limited by its faintness, they used the largest telescopes on Earth. Spectral analysis suggested Ymir was an icy world, dominated by water ice. Its surface appeared heavily cratered, bearing the scars of impacts. Unveiling its secrets would require a closer look, a mission to reveal its hidden wonders. Imagine a world cloaked in eternal twilight. Its surface a canvas of ancient craters and icy plains. This is Ymir, a tiny world in the Saturnian system, its secrets locked in ice and rock. Though small, Ymir is shaped by cosmic forces over billions of years. Its surface reflects the harsh realities of its existence. Countless craters mark its landscape, testaments to a violent past. These craters tell a silent story of cosmic collisions. Ymir's composition is a mixture of water ice, rock, and carbonaceous materials. The presence of water ice hints at a once active past. Ymir's surface is likely covered in regolith, a fine-grained mixture of ice and rock dust. This regolith would make traversing Ymir's surface a challenge for future explorers. Ymir, unlike Saturn's larger moons, follows an eccentric orbit, a testament to the chaotic forces of the early solar system. Its tilted path indicates Ymir is a captured object, ensnared by Saturn's gravity long ago. Ymir's average distance from Saturn is 23 million kilometers, making it one of the outermost moons. It takes Ymir 3.6 Earth years to complete one orbit, varying in speed along its elliptical path. Ymir, despite its diminutive size, holds clues to the early solar system. Its chaotic orbit and cratered surface hint at a bygone era. Scientists believe Ymir originated in the Kuiper Belt, later captured by Saturn's gravity, shaping its surface and composition. The craters on Ymir's surface are a record of chaotic events that shaped the early solar system. By studying these craters, scientists gain insights into the objects that collided with Ymir. Large craters suggest impacts with objects hundreds of meters to kilometers in size. These events release tremendous energy, resurfacing Ymir. Smaller craters indicate impacts with smaller objects. These impacts contributed to Ymir's surface erosion over billions of years. The uneven crater distribution suggests variations in impact rates. Higher crater densities represent older terrains, while fewer craters indicate younger surfaces. Mapping Ymir's craters helps piece together its bombardment history and the processes shaping icy worlds. Exploring Ymir's surface is like embarking on an expedition to a long-lost world. Every image, every pixel of data reveals new details about this enigmatic moon. Scientists have begun to piece together a preliminary map of its surface. Using telescopes, astronomers have captured images of Ymir at various wavelengths. Each wavelength provides a different perspective on Ymir's surface. These images reveal a complex and diverse surface. Ymir's surface is a mosaic of bright and dark regions. Large impact craters dominate the landscape. Smaller craters are scattered across Ymir's surface. Linear features suggest tectonic stresses or icy material flow. Impact cratering is the dominant geological process shaping airless bodies in the solar system, and Ymir is no exception. Ymir's surface bears scars of countless collisions, each impact leaving a unique imprint. The most prominent features are its impact craters, ranging from small depressions to large structures with central peaks. These craters provide valuable clues about the history of impacts in the outer solar system. While Ymir's surface is predominantly gray, a closer look reveals subtle hints of color variations. These differences could hold clues about Ymir's composition and history. Some regions appear reddish, while others are neutral gray. These variations could be due to surface material differences, such as organic molecules or iron-bearing minerals. Alternatively, space weathering could be responsible. Exposure to solar radiation and cosmic rays, along with micrometeoroid impacts, alters surface materials. While impact cratering is the dominant geological process on Ymir, there are hints that other forces may have shaped its surface. Linear features suggest tectonic stresses or icy material flow, hinting at a dynamic history. These features raise intriguing possibilities about Ymir's evolution. Further observations and a future mission are needed to unravel Ymir's geological history. Ymir, like many of Saturn's outer moons, presents a captivating puzzle regarding its formation. Its irregular, eccentric orbit hints at a capture scenario, suggesting it originated elsewhere in the solar system. But where did this icy wanderer come from, and what cosmic events led it to be ensnared by Saturn's gravitational embrace? The prevailing theory is that Ymir, along with other irregular satellites of Saturn, formed in the distant reaches of the Kuiper Belt, a vast, frigid region beyond Neptune's orbit. This region, a repository of icy remnants from the early solar system, is thought to be the birthplace of countless comets and dwarf planets. However, pinpointing Ymir's precise origin within the Kuiper Belt, or even confirming its birthplace with certainty, remains a challenge. The Kuiper Belt is a vast and sparsely populated region, and the early solar system was a chaotic place, with planetary migration and gravitational interactions scattering objects like Ymir across vast distances. Scientists hope that by studying Ymir's composition and comparing it to other Kuiper Belt objects, they might be able to identify its birthplace, or at least narrow down the possibilities. If Ymir's composition closely matches a specific population of Kuiper Belt objects, it would strengthen the case for its origin in that region. Determining the precise composition of a celestial body from millions of kilometers away is no easy feat. Astronomers rely on a technique called spectroscopy, which analyzes the light reflected from an object to identify the chemical elements and compounds present. Spectral observations of Ymir have revealed the presence of water ice, a common constituent of icy bodies in the outer solar system. However, the exact proportions of water ice, rock, and other materials, such as organic molecules, remain uncertain. This lack of detailed compositional information hinders our ability to fully understand Ymir's formation and evolution. The presence of organic molecules in particular would be of great interest to scientists. Organic molecules are the building blocks of life, and their presence on Ymir could provide insights into the distribution and evolution of these molecules in the early solar system. Future missions to Ymir, equipped with more sophisticated instruments, could provide the detailed compositional data needed to unravel the mysteries of its makeup. A spacecraft could analyze Ymir's surface composition in situ, providing a much clearer picture of its chemical inventory. The vast majority of moons in the outer solar system lack substantial atmospheres, their weak gravity unable to hold onto gases in the face of the sun's relentless radiation. However, there are some intriguing exceptions, such as Saturn's moon Titan, which boasts a dense, nitrogen-rich atmosphere. While Ymir is far too small and cold to retain a substantial atmosphere like Titan's, there is a slight chance that it might harbor a tenuous transient atmosphere. This atmosphere, if present, would likely be composed of gases released from its surface ice through a process called sublimation, where ice transitions directly from a solid to a gas. Detecting such a tenuous atmosphere would be incredibly challenging, requiring sensitive observations from Earth-based telescopes or, ideally, a dedicated mission to Ymir. A spacecraft could search for signs of an atmosphere by observing how starlight is absorbed or scattered as it passes through Ymir's limb, the edge of its visible disk. The presence or absence of an atmosphere even a tenuous one, would provide valuable insights into Ymir's surface composition, temperature, and interaction with the space environment. Ymir, though a small and seemingly insignificant world in the grand scheme of the cosmos, holds immense scientific value. Its ancient surface, preserved in a deep freeze for billions of years, offers a unique window into the early solar system, a time when our cosmic neighborhood was a chaotic and dynamic place. By studying Ymir's cratered surface, its composition, and its orbital characteristics, scientists hope to piece together the events that led to its formation, its capture by Saturn, and its subsequent evolution. Each piece of data, like a puzzle piece, helps to paint a clearer picture of the early solar system and the processes that shaped the worlds we see today. Ymir's story is intertwined with the stories of countless other icy bodies that roam the outer solar system, remnants of a bygone era. By studying these objects, we gain a deeper understanding of our own cosmic origins, the processes that led to the formation of our sun, our planet, and ultimately, ourselves. Ymir, a tiny world in the vast expanse of space, beckons us to explore, to unravel its secrets, and to listen closely to the whispers of the early solar system it holds within its icy embrace. Ymir may seem like an insignificant speck orbiting a giant planet, but its story is woven into the intricate tapestry of the Saturnian system. It's a member of a vast ensemble of moons, each playing a role in the grand gravitational ballet orchestrated by Saturn's immense pull. Understanding Ymir's place in this intricate dance provides insights into the system's history and dynamics. Saturn's moons are a diverse bunch, ranging in size from tiny moonlets to Titan, larger than the planet Mercury. They're often grouped based on their orbital characteristics, with regular satellites following predictable near-circular orbits close to Saturn's equatorial plane, while irregular satellites like Ymir take on more eccentric paths, often at extreme angles. Ymir belongs to the Norse group, a collection of retrograde moons named after figures from Norse mythology. These moons, including Ymir, share similar orbital characteristics, suggesting they might have a common origin, perhaps born from a single larger body that was torn apart by Saturn's gravity long ago. While Ymir's small size means its gravitational influence on Saturn and other moons is negligible, its presence contributes to the system's overall complexity and provides a valuable point of comparison for scientists studying the dynamics of planetary systems. The Saturnian system is a dynamic environment, with dozens of moons, countless ring particles, and even passing comets all interacting through the invisible force of gravity. Ymir, despite its small size and distant orbit, is not immune to these interactions. Its motion is subtly influenced by the gravitational tug of its fellow moons, particularly those in nearby orbits. These gravitational interactions, though subtle, can have a profound effect on Ymir's orbit over long periods. Over millions of years, these interactions can cause a moon's orbit to evolve, becoming more or less eccentric, shifting in inclination, or even leading to collisions. Scientists use sophisticated computer models to simulate the motion of objects in the Saturnian system, taking into account the gravitational influence of Saturn, its major moons, and even the rings. These simulations help to unravel the complex interplay of gravitational forces and to understand how the system has evolved over time. By studying the orbital dynamics of Ymir and other irregular satellites, scientists hope to gain insights into the processes that shaped the outer solar system and the role of gravitational interactions in the evolution of planetary systems. The study of Ymir and other irregular satellites is not merely an exercise in celestial mechanics. It provides valuable data points for testing and refining our understanding of planetary formation. These distant, icy worlds hold clues to the early solar system's conditions and the processes that governed the formation of planets and their moons. Current planetary formation models suggest that the giant planets, including Saturn, formed in a protoplanetary disk of gas and dust that surrounded the young Sun. As these planets grew, their gravitational pull sculpted the surrounding material, accreting gas and dust to form their cores and sweeping up smaller planetesimals to create their moons. However, the capture of irregular satellites, such as Ymir, presents a challenge to these models. Capturing a free-roaming object into a stable orbit requires a specific set of circumstances, typically involving a close encounter with the host planet or interactions with other objects in the system. By studying the orbital characteristics and compositions of captured satellites like Ymir, scientists can refine their models of planetary formation and gain insights into the dynamical processes that shaped the early solar system. These studies provide valuable clues about the prevalence of capture events, the role of planetary migration, and the conditions under which planetary systems evolve. We've journeyed far, from the familiarity of our own planet to the icy outskirts of the Saturnian system. There we encountered Ymir, a tiny world dwarfed by the gas giant it circles. Yet, as we've seen, size is no measure of cosmic significance. Ymir, despite its diminutive stature, holds within its frozen frame a story that stretches back billions of years to the very dawn of our solar system. We've explored its cratered surface, a testament to the relentless bombardment that shaped the early solar system. We've pondered its irregular orbit, a telltale sign of its capture by Saturn's powerful gravity. And we've delved into the mysteries of its composition, searching for clues to its origin and the secrets it holds about the early solar system's chemical makeup. Ymir stands as a reminder that the universe is filled with wonders, both great and small. Each celestial object, from the largest star to the smallest moon, has a story to tell, a history waiting to be unraveled. And as we continue to explore, to push the boundaries of our knowledge, we unveil not only the secrets of the cosmos, but also our own place within its grand design. Today, Ymir remains a distant, enigmatic world, its secrets hidden behind a veil of distance and ice. But the quest to understand this tiny moon is far from over. Future missions to the Saturnian system could revolutionize our understanding of Ymir. Imagine a spacecraft capturing high-resolution images, revealing intricate details of its surface. Such a mission would be a scientific treasure trove, unraveling Ymir's mysteries. As we conclude our exploration of Ymir, let's consider the broader cosmic perspective. Ymir, a tiny moon orbiting a giant planet, is one of countless celestial objects in the universe. Its story is a testament to the interconnectedness of the cosmos. The same laws of physics govern Ymir, distant stars and galaxies. Ymir's atoms were forged in long-dead stars, scattered in supernova explosions. Ymir's story reminds us we are part of a cosmic web of matter, energy, and time. By exploring the universe, we gain a deeper appreciation for our place within it.